Welcome to the first and only lesson for today. We're going to go over even and odd functions, something that you hopefully heard about last year, and this will mostly just be review. What we're going to do, guys, is we are going to go over these little templates of definitions, characteristics, examples, and non-examples of even and then odd and then neither. What I would recommend for easy notes is after each one is complete, just pause the video and take a screenshot of just the little template and put in some document for reference, guys. That'd be a really good idea. All right, so let's go over this real quick. So for definition for even, it is simply a function that's symmetric around the y-axis. If you wonder what symmetrical means, we're talking about things that are perfect reflections, and imagine the y-axis as being a mirror. We'll see some examples of that, some visual examples of that in just a moment. Characteristic wise, guys, we're talking about things that have only even exponents, and if you ever try to flip it around the y-axis using, transformations that we talked about, put a negative inside the parentheses, it's going to look exactly the same. It's going to be exactly the same as how it was originally. So here's an example of that right here. Take a look at this graph. Notice how the left side is like a perfect reflection of the right side. If I flipped it around the y-axis, it would look exactly the same. An example of an equation of that would be like these two right here. These are not the equations of this graph. I just want to make that very clear. But if you take a look at these equations, you will see that the very bottom one has only even exponents, and the top one has even exponents, and you can have a constant for even functions. It's totally fine. Some of that would not be a even function. Would look more like this. See how like lopsided it is? Wouldn't work out. Okay, and that's even functions. Make sure you take a picture of this if you can. Let's go over odd functions. So for odd functions, it's a bit different. And it is symmetric, but it's not symmetric around the x-axis or the y-axis. It's actually a perfect reflection over the origin. That's the exact center of the of of the uh, of the graph. So characteristics of that, guys, would be odd exponents, of course, but no constants, no numbers by themselves. I'll show you when that would be actually bad. And then um, way you tell this is if you flip it over the x-axis and then you flip it over the y-axis, it'll look exactly the same. So if you do a double reflection, or if you reflect it once, it'll look as if you did the other reflection too. So some visual examples of this would be right here. Notice how if you notice how they're pretty much symmetrical if you're looking at like sideways, like a diagonal. You also could tell that, hey, if I flipped this graph upside down, the middle one, it would look exactly the same as if I flipped it left and right. Um, an example of this would be y equals x to the 5 minus x to the 3. Notice there's no number at the very end. If it has any number at the very end, it cannot be an odd exponent. It can't have like a +2 or whatever, because it has to go through the origin, effectively. Either it has to go through the origin, or um, it can't go through the y-axis at all. So some examples of that not working is, take a look at this one. Notice it's very similar to some of the ones on the left, but it doesn't go through the origin, so we know it can't be an odd function. So just to show you guys some examples of graphs that, or functions that are neither odd nor even, um, if I take a look, the definition is pretty much a function that is neither odd nor even. So you're wondering, how do I define this? You just say it's not odd or even. That's all. So some characteristics, it has even and odd exponents. And some examples of that as a graph. Look at this. Notice how it's lopsided, so it can't be even. And it's not really perfectly symmetrical around the origin, as if it were odd. And here's some equations for that. Notice how the first one has an odd, which is exponent, which is 3, and then even exponent, which is 2, and then a number at the very end. That wouldn't work. Same thing with the second one. Has a bunch of even and odd exponents. You know that just can't work out. And some non-examples are things I showed you in the past. Pretty much anything that looks symmetrical is almost always going to not be a neither. If it's symmetrical, it's almost always either going to be an even function or an odd function. It just matters what it's symmetrical around. And that's it for today's lesson. Make sure you guys are here on time for the class on Tuesday, because first off, everyone's going to be here on Tuesday. It's going to be one of those minimum days, so it's going to be pretty fast paced. Otherwise, guys, good luck with the work. It's only a few problems, and you have a good day. Bye.